sine squared anything plus cos squared that same thing gives you 1.
Okay. So is it 1?
Yep. Doesn't matter so long as they're the same thing.
Okay.
Let me now do B, but I need to do some teaching first. Sine squared theta plus cos squared theta equals 1, let's say. What is sine squared theta equal to?
Would it be equal to a half?
No, make sine squared the subject.
Divide sine on both sides, sine squared on both sides.
No. Just move the cos over.
Oh. But you just minus it.
Yep.
So it'd be minus sine squared. Theta equals minus sine squared.
No. Sine squared theta plus cos squared theta gives you 1. What is sine squared theta equal to?
Cos squared theta.
Subtract cos squared theta from both sides.
You get minus cos squared theta.
You already have something else on the right side.
You have 1.
And so, what's on the right side now? What's
1
on?
minus cos squared theta.
Well done. Okay. Similar idea. Sine squared theta plus cos squared theta equals 1. Subtract sine squared from both sides.
Cos squared theta equals 1 minus sine squared theta.
Well done. And so sine squared theta is 1 minus that. Cos squared theta 1 minus the other.
Yeah.
So that's all I'm getting at. Okay, let's try part B.
So would part B just be adding or minusing 5 on both sides?
There's no sides. It's just an
Okay.
expression. Try factorizing.
Could you put 5 on the outside?
Yep.
And then brackets minus 1. Without, no, 1 minus 1 sine squared theta.
Yeah. And what is 1 minus sine squared theta the same as?
Same as
What's 1 minus sine squared theta equal to?
cos squared theta.
That's it. And that's simpler because it's not two things being subtracted. It's just one thing. Question C. Can you use that?
Could you divide by both sides? Multiply.
I would change the bottom.
Okay. So could you factorize the bottom?
No. Change it. At the moment it's 1 minus sine squared 2 theta.
Could it be cos squared theta
Well done.
minus sine squared
No.
2?
Sorry, 2 theta.
Yeah.
So cos squared 2 theta. Yep. Okay, so sine 2 theta over the square root of cos squared 2 theta. Any idea what you do next?
Or could you simplify it?
How?
Would the 2 theta cancel out?
You would have to square root first. Bidmus.
Okay. C square root cos squared 2 theta.
Yep. Any idea what you get?
No.
And it's the same as where did I write this? Yeah, sine squared A just means sine A all squared.
Okay.
And so cos squared theta means cos theta squared. And so what would be the square root of cos theta squared?
Cos squared theta.
No. What happens with square root and square root?
Oh, they cancel out.
Yeah. And so what are you left with?
Cos theta.
Yes. And so you're left with just cos theta in this case. And so how about this one?
So would it be cos 2 theta?
Yep. So you have sine 2 theta over cos 2 theta. Any idea what that is? Sine over cos?
No.
That is the same as tan 2 theta.
Okay.
Sine over cos equals tan.
Okay.
Okay, we'll look out for this. Oh boy, they're not messing around. Oh boy. Maybe. Yeah, maybe it might not be the worst thing to just jump into that now.
Okay.
Let me just see what these look like. This looks good. Let's do this one.
Okay. So should we minus 2 on both sides?
No. What does the question have that the answer doesn't?
It's equal to 5 and it has 7 cos rather than 4 and 3 cos. Well, cos and sine, 3 sine.
Biggest difference is that the question has sine, answer doesn't.
Yeah.
And so can we rewrite sine squared x in terms of cos?
Would it just be cos squared theta? Sine squared x plus cos squared x equals 1. Okay.
Make sine squared x subject.
Cos squared x equals 1 minus sine squared x.
And so sine squared x equals?
1 minus cos squared x.
Okay, so use that to eliminate sine squared x in our question.
So could you rewrite it as 3 brackets 1 minus cos squared x?
Well done. And now let's simplify.
Okay. So can we multiply everything in the bracket by minus 3?
Yep.
Okay. So when -3 multiplies by minus cos squared x, what would that give you? Would that just give you 3 cos squared x?
Yep. Minus times minus makes plus.
So it'll be 4 cos squared x, 3 minus plus 3 cos squared x.
Yep. Okay, simplify.
Okay. Could we get rid of the 2 on the other side?
Well, let's. We have in the answer the numbers are on the right, so move the numbers to the right, and
So could you plus 3 on both sides?
yep.
Which gives you 4 cos squared x plus 3 cos squared x equals 5. Then you can add the 2 causes together, which gives you 7 cos squared x equals 5.
And so that's what we were asked to find. Great. And so swapping between those two works. Let's see. Okay, now it's a good time to go back.
Okay.
Let's do part B.
Okay. So do we need to change 4 cos squared theta into a sine?
Yep.
Okay. So it'll be 4 open brackets 1 minus cos squared theta close brackets, and then minus 5 sine squared theta.
Yes.
And then you multiply everything in the brackets by 4,
Yep.
and then simplify.
Yep.
Which would be 4 minus 4 cos squared theta minus be 4 minus 4 sine squared theta minus 5 sine squared theta.
And fully simplifying.
It would be minus 9 for
That's final answer.
okay. So it would be 4 minus 9 squared theta.
9 sine squared theta. That's it. Well done. I think you've got the hang there.
Yeah.
Now let me do. Kind of weird. Maybe. Okay. Any idea about this one?
Okay. So when substituting 3 cos theta into p, would the square need to be inside or outside the bracket?
The way I would do this, I would make cos theta the subject first, and then get cos squared theta, and then do the same for sine.
Okay. But why do we need the... Wait. Oh, okay. So would it be 9 cos theta?
Hold on. So what would cos theta be equal to?
3. Well, no. P. Oh, no. 1 over P.
Think about it.
Oh, it's equal to sine theta, right?
Divide both sides by 3.
1 over 3. P over 3.
So p over 3. And so cos squared theta?
P squared over 3.
P squared over 9.
Oh.
Okay, same idea with sine.
Okay. So sine squared theta equals q squared over 4.
Well done. That's equal to sine squared theta. Okay. Sine squared theta plus cos squared theta equals 1.
1.
Sub in the values that we have.
Okay. Wait, when you say sub in the values, where like into sine squared theta plus cos squared theta equals 1?
Yeah, so what is sine squared theta the same as?
Oh, it's the same as q squared over 4.
Mm-hmm. And what
Plus
is...
p squared over 9.
Yeah. That's equal to 1.
Yeah.
And then make it look like their one.
So now would you sub in for cos 3 cos theta?
No. Times everything by 36.
Oh. So it would be 36q squared.
Well, what is 36 divided by 4?
36 divided by 4 is 8, I think.
No.
Wait, no, it isn't. It's 9.
Yeah. So that's 9q squared.
And then 36 divided by 9
Yep.
is 4.
Yep.
Which is 4p squared. Yeah.
Mm-hmm. Equals?
9q squared, 4p squared.
Yeah, equals. Right side?
36.
Yes, well done. And so that was using, you make it, sine squared equals cos squared equals, and then you go from there.
Yep.
Any questions about that one?
Nope.
Okay, so let's see if there's another similar one somewhere else that's not similar. No. Okay, we did what we needed. Okay, any idea how we do these?
Okay. So for the first one, you need to make it cos theta to cos squared theta first.
Yeah, well done.
So would you square minus 3 over 5?
Mm-hmm.
Minus. Which gives you minus 9 over 25.
Minus times minus?
Positive, so it'd be 9 over 25.
Yeah, you have to put it in a bracket.
Okay.
Okay, what's next?
And then do we make sine the subject?
Well, cos squared theta equals 9 over 5, or 9 over 25. We have to get what sine is equal to. So how could we bring sine in somehow?
Okay. So would sine squared theta equal mod 1 minus cos squared theta?
Yeah. And so cos squared theta equals?
Cos squared theta equals 1 minus sine squared theta.
Yeah, so how do we use that?
So could you write it out as cos squared theta equals 9 over 25 brackets 1 minus sine squared theta?
No, instead of cos squared theta, you write
sine squared 1 minus sine squared theta.
Yeah, because they're the same as each other.
Yeah. And then would you multiply by 9 over 25?
Just try to make sine theta equals. So you can start by trying to make sine squared theta the subject.
So would you need to get rid of the 1 minus first? Or the 1?
Let's bring the sine squared to the right. What would it be?
Minus 1 minus sine squared theta.
If you bring the sine squared theta to the right side?
Would you need to minus it, or do you have to divide to get rid of it?
It's already minus.
Oh, so you add.
Yeah.
So it'd be 9 over 25, add sine squared theta.
Yeah. 9 over 25 plus sine squared theta. Okay, we want it to be just sine squared theta.
So can you minus 9 over 25 on both sides?
Yep.
Which gives you 1 minus 9 over 25 equals sine squared theta.
Yeah. Calculator, 1 minus 9 over 25.
34 over 25.
I think you did plus.
Wait.
Or minus minus.
1. Oh, I think I did, yeah. 1 minus 9 over 25. 16 over 25.
Yeah. And so 16 over 5 is the same as sine squared theta.
Yeah.
What is sine theta?
Square root of both of them.
Yep.
It's 4 over 5. Or, let me see. 0.8.
Technically it's plus or minus 4 over 5.
Okay.
We're told the angle is reflex.
Yeah.
Which quadrant will that be in? If it's reflex.
Would it be the bottom left, top left?
So let's see. So this is 0, 90, 180, 270, and then back to 360.
Oh, so it'd be the bottom two.
So it's in here. Okay. Which of the two, given that cos theta is negative?
Would it be the cos quadrant then?
That would be if it was positive.
So it'd be the tan quadrant.
Yes.
So the bottom.
So it's in between 180 and 270. And so which will sine theta be? Will it be positive or negative?
Negative.
Yes. And so sine theta is equal to minus 4 over 5.
Okay. But how do you know if it's... Wait. Is it if it's below the line in the quadrants? Does that mean it's negative?
No. Tan is negative. Sorry, tan is positive between 180 and 270. Cos is positive between 270 and 360. But for this one, we know that cos is negative and it's reflex. And so it's in the third quadrant, the tan positive quadrant.
Okay, yeah.
And so we know that sine and cos are negative in between 180 and 270.
Yeah.
Okay, a similar idea, part B.
Okay. So I got sine alpha squared equals 2 over 5.
Equals 2 over 5
sine squared 4 over 25, sorry.
Yeah. Alright, we're trying to change.
And then you want to make sine alpha squared cos squared alpha squared, 1 minus cos squared alpha.
Mm-hmm. So what does 1 minus cos squared alpha equal
up? Sine squared alpha.
Yep. And what else?
4 over 25.
Yep.
So would you write it out as just 4 over 25, just like that? Or would you need to put sine alpha squared with it? Or is sine alpha squared 4 over 25, so you don't really need to add anything else?
Yeah. So sine squared alpha equals 4 over 25. Sine squared alpha equals 1 minus cos squared alpha. And so 1 minus cos squared alpha is equal to 4 over 25. They're both equal to each other. Sorry, they're both equal to the same. They're both equal to each other, so they're both equal to the same thing.
Okay. I got the final answer as 0.917 equals cos alpha, rounded to 3 significant figures.
No. Go on, what was you working out?
So I did, so I minus added cos squared alpha to both sides.
Mm-hmm.
So I got 1 equals 4 over 25 plus cos squared alpha.
Mm-hmm.
And then I minused it on both sides, minus 4 over 25 on both sides.
Mm-hmm.
And I got 21 over 25 cos squared alpha.
Ah,
equals cos squared alpha.
I see. Exact value. And so, what is the exact value for cos alpha? Not the decimal?
Oh, square root of 21 over 5.
That's root 21 over 5.
Yeah. Plus or minus.
Well done. Okay, but which one?
Okay. So we know it's obtuse, meaning that it can't be a reflex, so it can't be the bottom two in the quadrant.
Yep. There's one more quadrant it can't be.
It can't be the top right quadrant.
Yep. Obtuse is in there.
Yep.
That's why sine is positive 2 over 5.
Yeah.
And so we have cos alpha is a
Cos alpha equals root 21 over 5. Is that the answer?
positive or negative?
Positive.
Sine alpha is positive because sine is positive in the top left quadrant.
Okay.
Everything else is negative.
Wait, so would it be negative then?
Yep. Cos is negative between 90 and 180.
Okay.
And so cos alpha is negative root 21 over 5.
Yeah.
And if you sketch the cos graph, it goes like that.
Yeah.
From 0 to 90, it's positive.
Yeah.
Then from 90 to 180, negative. 180 to 270, still negative. And then 180 to 360, positive. And that's here, 180 to 360. This quadrant thing is just a summary of where what is positive where, or what is positive when. They're all sine, cos, and tan are all positive. Can you hear me?
Hello? I can hear you now, yeah.
Okay. Yeah, so this quadrant thing is just a summary of what is positive where.
I think the screen's frozen. I can hear you, but the screen's frozen. Oh, now it's unfrozen, I think.
Oh, okay.
Yeah, I can see it now.
Yeah? Okay.
Yeah.
Great. So exam questions, these are going to come up, no doubt. Not just yet. Yeah. Oh, they're not messing around. They're not messing around. Okay. Let's see. The cos of B. Let's see. Not just... Okay, better do it. How about this?
Okay. A. The first one, A.
Yeah.
Okay.
Better do both of them.
So would you use the cosine rule?
Yep.
And the cosine rule is c squared equals a squared plus b squared minus 2ab cos c.
Yep. Okay. What goes where?
So could you say, when it says to find the exact value of cos b, does that mean the angle, right?
Yeah.
Okay, so you could do 12 squared equals
No.
7 squared
No.
plus...
No. No. So B.
Yeah.
The important bit is the side opposite.
Oh, so it's 9.
Yeah.
So it'd be 9 squared equals 12 squared plus 7 squared minus 2 brackets 12 brackets 7 and then cos c.
Yeah. All right. X. So how do you go about this one?
You just put it all into the calculator.
All right. Let's try it. Oh. Shift calc for solve.
Now I got 48.189.
Okay, but they said exact value. Press answer equals.
I got 48.89.
Looks like we have to do it the old-fashioned way then. Hang on. Yep. Ah. Can you hear me?
Yeah, I can hear you now.
Okay. Actually, I realized if you're still able to edit it, you're probably not able to. We're not trying to find. We're not trying to find B. We're trying to find cos B. So you wouldn't write cos X. You would just write X.
Okay.
So shift solve. So I'll do it. Lucky 7. Roll the dice. I know you. So that's what I get. And if I press answer, it's 2/3.
Okay.
Okay, so cos C, sorry, in this case cos B is exactly 2/3.
Yeah.
Part B.
Okay. So would you do inverse cos 2/3?
Okay.
Which gives you 48.896851.
So that's what we got before. And
Yeah.
so we want sine B.
Oh, they want sine B. Okay.
Mm-hmm. So what you have there is B. What is sine B?
So cos theta can be written out as 1 minus sine theta.
Yeah, let's take a chance though. Let's take a chance.
Okay.
Arc cos of that is this 48. So then that's B, and so sine B is sine answer. Oh, it didn't work. Yeah, we have to do it. Okay. Yeah. So cos B.
Hello? I can't hear you again.
Cos B is 2/3. Can you hear me? I'll try to do some stuff with my internet. One sec. I'll just leave that like that. Cos squared B equals, and then sine B equals.
I can't hear you if you're there.
Can you hear me? Hello, can you hear me?
Yeah.
So, I tried some monkeying around with the internet. Okay, cos B is 2/3. We want sine B.
Okay. So it can be rewritten as 1 minus sine B.
1 minus sine squared B.
Sine squared B equals 2/3.
Yep.
And then you'd add sine squared B to both sides.
Mm-hmm.
So it'd be 1 equals 2/3 plus sine squared B.
Mm-hmm.
And then you'd take away 2/3 on both sides.
Mm-hmm.
Which gives you 1/3 equals sine squared B.
Let's see. Yep.
And then could you square root both sides?
Yep.
Which gives you plus or minus square root of 3/3 equals sine B.
Okay. Exact value. Which one?
Okay. So we know the angle is in the top right quadrant.
Yep.
But how do you know if it's positive or negative?
They're all positive up there.
So it's the opposite.
No,
Or
they're
just positive.
yep. They're all three are positive up there.
Oh, okay. That makes sense. Yeah, I remember now. So it's positive.
And so, answer?
Sine B equals square root of 3/3.
Yeah. Well done. Wait, root 5/3? That might be a... They're wrong.
Okay.
That's a misprint. 2/3. Yeah, I mean, 2/3 isn't very complicated. 1 minus 2/3 is 1/3.
Yeah.
And I'll show you what your calculator did. If you do the square root of 1/3, that automatically rationalizes the denominator.
Yeah.
Even simpler, 1/√3. It's automatically rationalizing the denominator.
Yeah.
And yeah, it's definitely root 3/3, not root 5/3.
Yeah.
3. Yeah. Okay. Let's do this one.
Okay.
Here's a reason.
So would you use a sine rule for this?
Sine of P. Yep.
So would you 10 over sine x is equal to 9 over sine 45?
It's easier if you put the angles on top if you're finding an unknown angle.
Okay, so it'd be sine x over 10 equals...
You can call it sine P.
Okay, sine p over 10 equals sine 45 over 9.
Mm-hmm.
And then could you just put that into the calculator?
Show that. They gave you the answer, so...
Okay.
Or what are you putting in the calculator? Sine 45 over 9?
Yeah, and
Yep.
that's equal to it. Sine. So sine p over 10 is equal to square root 2 over 18.
Mm-hmm.
And then could you divide on both sides?
It's already divided by 10.
Okay, multiply by 10 then.
Yep.
So would sine p equal to, how do you do? Is equal to 5, and then you can just multiply it by 10 in the calculator, which is equal to 5 root 2 over 9.
Yeah. That's it. We've shown it. Okay. Question B.
Okay. Okay. So could you write out as 1 minus sine squared p equals 5 square root 2 over 9?
Write it as what, sorry?
Could you write it out as 1 minus... Wait. Would it be 1 minus cos squared p?
You could, but we don't know sine squared p yet.
Oh, so we just square it.
Yep.
We square the answer. Which gives you 50 over 81.
Okay.
So would you do 1 minus cos squared p equals 51 over 81? 50 over 81, sorry.
Mm-hmm.
Equals. Then you'd add cos squared to both sides.
Yeah.
1 equals 50 over 81. Add cos squared p.
Mm-hmm.
And then you'd minus 50 over 81 on both sides.
Mm-hmm.
Which gives you 31 over 81 equals cos squared p. Then you'd square root both sides.
Mm-hmm.
Which gives you square root 31 over 9 equals cos p. Plus or minus cos p. Or plus or minus 31 over 9.
Mm-hmm.
Square root 31 over 9. I mean, I know it's obtuse, so it'll be in the top half of the quadrants.
Mm-hmm.
And wouldn't it be in the top left and it'd be negative, right?
Yep.
So it'd be cos p is equal to minus square root 31 over 9.
Well done. Let's answer for part A. Oh, I don't have B. But yeah, you got it. Let's see. Oh, that's a good one. But yeah. I think you got the hang of those.
Yeah.
Yeah, what do you give yourself?
Probably a half.
It's good. I think trig identities are the hardest.
Yeah.
But anyway. And so, how was that for you, Adam?
That was okay. Yeah.
It's 3 sections into chapter 2, or a third over the way. Any questions for me in general?
No.
Alright, well done, Adam. You did great. I look forward to talking again next time.
You too.
Alright, take care. Goodbye.
Bye.
Bye.